All right, hello everybody. Adam with FANUC here again. Um, got another neat request here recently, and I figured I'd put it into a quick little tips and tricks video. Jumping right in, had somebody ask me, hey, I'm familiar with the program speed setup, our override select. Say, hey, this is great. That's all good news. Use digital inputs, but I only get 4 speeds. You could have a low, medium, a medium, and a high. They said, but what if I want granularity? I want to be able to really pick my speed on the fly as I go. So that prompted this video, and I want to show you some tricks of what I've used in the past. So the first thing I want to point out is I normally start my programs with a line of code that defines the speed. That's just a safety thing. I just want to make sure that I know how that robot is starting. So for this video, I've gone ahead and remarked that out so it doesn't exist, because I'm going to be calling the speed autonomously with better resolution. This could be something from your PLC, an HMI input, an input from a touchscreen on your Teach pendant using a browser window that you've built, and a multitude of things. But at its core, basically what I want is I want a variable that writes to register 2, or pick a register. But again, this will come from a PLC, an HMI, what have you. And we're going to write a speed to a register. We're going to populate that register into this guy. So work with me here. We're going to create a new program. Create. I'm going to name mine speed control. The critical part for this is I want to go into my details screen, and I want to pull it out of group 1. Group 1 is robot motion, and the program I'm about to write, although it affects motion, it's not going to have any motion statements like a linear move, a joint move, a circle move, etc. So I'm just going to turn this to an asterisk right there, and this makes this allowed to be run in the background. So here we go. We have a speed control program. Let's just put in a few lines of code. Doesn't really matter. Kind of the strategy, the secret sauce that I like to use is a quick decision-making process that says, when do I want to pay attention to this? So I'm going to put in an if statement that looks at the built-in function, a user output number 8. This is looking at the teach pendant. Is the teach pendant turned on or off? Odds are, if you have the teach pendant turned on, you're jogging the robot, and you're going to want control of this speed. You don't want the PLC to tell you how fast you're going when you have control of the teach pendant. So I'm going to build this to say, I only want this code to run if the teach pendant is off. If the teach pendant is off, then what do we do? But if that teach pendant goes on, that means the human is in control of this game. So I can use these buttons down here, faster, slower. And as I do that, you can see the speed changing up here. So here we go. If the teach pendant is off, let's give control to a PLC. I'm going to go to my register data. I'm going to use this bottom one right here, where it has parentheses means I can customize it. So I'm going to click on this, and I'm going to use parameter. You're going to have to manually type this. There's no selection list. You gotta know what you're typing, but it's going to be the motion control variables dot gen override. That's the general override. Okay. I'm going to make it be equal to register 2, speed, the one that we set up, whatever register you're using. And then, of course, we got to do our housekeeping. There we go, end if. There's our code, guys. If the teach pendant is turned off, then let the robot speed be whatever a PLC or a HMI is telling it to be. So there's your program. But you can see right now, nothing's happening. The last step, menu, setup. We're going to go over here to this BG logic, background logic. And I'm going to have this program in here, if it wasn't there, choice, speed control. Then you can see right now it's in a stopped status. All I have to do is click run. So as soon as this is running, it is running at all times. Every 8 milliseconds, that program is updating itself. Doesn't matter if you're in auto mode or teach mode or what you're doing. It's running from now until I tell it to stop, basically. So you set it and you forget it. So if I go over here and I look, you can see on my screen that my teach pendant is turned on and I'm at 80%. If I turn this off, there we go. The teach pendant is turned off. We're at 25%. So now the PLC tells me, hey, I want to run at 36%. Boom. It writes directly in there. So let's test this in a program and see what that looks like. So if I go over here, I'll call up my main program from something that I've written in one of my other videos. Let's go ahead and execute this. Okay, so I've got a robot that's just dancing back and forth at 36%. Let me move the... You'll see that these buttons don't do anything. I'm clicking. You see them highlighting up and down. Doesn't matter because the PLC is in control. If I put in a 5, there's your nice and slow robot right there, 5%. Let's go up to 15%. Boom. Get a little bit faster. Keep in mind that if you put in a 0 and press enter, you get a warning that says that's an invalid gen override. Not going to work. But it'll interpret it as the nearest whole integer. Even if you try and trick it, 22.9. All right, it's just going to truncate. All right, it says, well, that's a 22 in my world. You know, you want 23, you give it 23, because we only deal with integers. But at its core, hey, now you can get your robot going fast and slow on the fly from your PLC or your HMI. Without having somebody need to pick up a teach pendant and touch the buttons, and without having to use those 4 inputs. So I hope these tips and tricks help you. Good luck programming and have fun.